transport chain is tightly coupled to this process of making ATP. This part we call oxidative phosphorylation because it involves redox reactions, like you're oxidizing NADH, and it leads to this process of synthesizing ATP. So electrons being pulled out all the way through, going to oxygen. Oxidative phosphorylation, we're using the energy in those redox reactions to drive ATP synthesis. And don't forget, we talked about this last time, here's, we're showing NADH being oxidized, donating its electrons. We have these 4 different complexes. Electrons flow to complex 1, anticolin's on Q, ubiquinone. From there, ubiquinone hands them off to complex 3, to cytochrome C, complex 4, and then back inside where they get handed off to oxygen. But it's not just these electrical currents per se. Every time it passes through complex 1 to Q, 4 protons are pumped. Every time electrons flow through complex 3, 4 protons are pumped. Complex 4, 2 protons are pumped. So if you move a pair of electrons off NADH to oxygen, you're pumping out about 10 protons across the membrane. If you talk about FADH2, that donates at this point, bypasses this, you get a little bit less energy conservation out of FADH2 compared to NADH. But they both pump protons. They're doing work, building up a proton gradient. And this is how we extract energy out of it. Those protons are going to come back through this thing, which is the ATP synthase. Comes back through a special portal there that drives ATP synthase.